So we are talking about second derivatives because we want to use them to talk about the concept of concavity, which is about to be introduced. So a curve is considered concave up if its slopes are increasing. So for example, let's say as we move from left to right along this graph, the first derivative is -4. Doesn't matter that it's a -4. What we care about is we go further down the x-axis. If the next derivative is -1, still a negative number, but it's larger in value. And the next derivative is +6, again, a larger number. So as we keep going from slope to slope, if they're getting bigger, those are increasing slopes, and so we are in a concave up region. The converse is true for a concave down region. It is when the slopes are decreasing as you progress from left to right along the graph. For example, let's say we start with some g function and have a derivative of 7 at a particular x value, and a larger x value has a smaller derivative. And as we keep going across left to right, we have an even smaller derivative. So it doesn't matter that the numbers are positive or negative. What we care about is as you progress from left to right, if the numbers keep getting smaller, then we're seeing a decrease or a decline in our slopes, and we're in a concave down region. Here it is visually. Concave up. Think of a graph that's headed upward or a regular upward facing U, the letter U. And I've given these arbitrary slopes over here. So a -4 slope would be a pretty steep downward negative slope. -1, still a negative number, but it's not as steep. My graph is kind of flattening out. But then f prime equals 6, I have this positive slope. What you don't see yet, but you will soon, is if we had an actual derivative, even though we could plug in numbers to get all these different first derivatives, the second derivative for every number in this region, positive. Doesn't matter which x value we pick in this section, all derivatives will be positive. Their first derivative may be negative, but the second derivative won't. The same is going to go reverse for concave down. So think of this as a U that is upside down, a U that is pointed down towards the ground. It may have a steep positive slope over here on the left, but as we progress across the graph towards the right, we keep getting these smaller and smaller slopes. And so our second derivative will be negative.